Bismillahirrahmanirrahim. In today's lecture, we will be discussing some practical example of memory management. Here we will be talking about practical implications of main memory management. We have already discussed main memory management in chapter 6. So here we would find some code snippets and see how we can code the problems related to main memory management. The discussion agenda is in front of you. We would see or we would recap the dynamic partitioning as we have discussed in chapter 6. Main memory is partitioned in two ways: fixed partitioning and dynamic partitioning. So in today's lecture, we would recapitulate the dynamic partitioning and also the problem it brings. The problem is external fragmentation. What is it and how we can code it to detect external fragmentation? So we would write a code snippet for detecting the external fragmentation issue and also observe its sample output. So let's start. First topic of discussion is to recapitulate what is dynamic partitioning. So the dynamic partitioning, the partitions are made on the basis of process size and they are very flexible. That means partition can change its size as per the size of the process. At start, the main memory is empty strand and one by one partitions are created on the basis of size of the process. No matter how big or small a process is, exact size partition will be created for it in main memory until we reach to the point where very small spaces or holes, also known as Coulson holes or simply holes, are created throughout the main memory. These holes are so small that no process of this much size may be present. So these holes are known as external fragmentation, as these are located outside of the partitions made and they are readily available to be used by any process, but since they are so small that no process can occupy. So operating system will apply compaction technique to handle this problem. Compaction will collect all the holes and make a big partition at the end of the memory, which is large enough to hold a process. IBM multi-programming with a variable number of tasks operating system is implemented using dynamic partitioning. I hope you might have understood what is dynamic partitioning and how it creates external fragmentation. So now we are going to discuss a code snippet that helps in detecting external fragmentation. This is a code snippet. Complete code can be found in the attached Word document on your KCMS. In this code, we are going to detect the external fragmentation if it is present in main memory and how much sizes and when to apply compaction. Once you will run the code, what sample output you will get? The code will produce the following things. It would require you to enter memory capacity, which is divided among different processes. So how much memory you are going to provide to different processes, you have to enter its capacity, and then total number of processes that you want to be stored in that available capacity. Then you have to also mention memory requirement size of every process, so that according to every process size, memory is divided, partitions are made, and then free holes are counted on and compaction is applied. At the end, this code will generate the calculated external fragmentations, total number of external fragments, which are generated by the number of processes you have entered. Then that would be the time to run compaction technique, and it is normally run by operating system itself. That is all for now. I thank you all.